problem on exact differential equation. Find all functions m such that the equation is exact. So, and the second problem is find all functions n such that the given equation is exact. That is, we assume that this equation is exact and find the value of m. That is, for which value of m this equation is exact. We have to determine for which value of m uh, this differential equation is exact. And we know that any differential equation of the type m dx plus en dy is equal to 0 is exact if dA by m by dA by y is equal to dA by n by dA by x. What is dA by n by dA by x is 2x. That is, we have to find the function m xy such that its derivative with respect to y is 2x, not 2y, 2x. That is, if we have to find that. So all these problems, and here we have to find the function n in a such a way that where this dA by m by dA by y is equal to dA by n by dA x. Okay, so assume that this differential equation is exact and then find the value of m and n. So answer of some problems. These are the problems for homework. So answer of this problem number 1, 5-1. So how we can solve these type problems? So answer of that 5-1. So assume that the given differential equation is exact. 5-1 m xy dx plus x square minus y square dy is equal to 0. And we have to find the value of m such that this equation is exact differential equation. So we suppose that this differential equation is a exact differential equation. So we have what we have. If we assume this differential equation is exact, we have dA by m by dA by y is equal to dA by n by dA by x. This is the necessary excitation condition for the differential equation to be exact. And then what we have? DA by m by dA by y. M is m. So write dA by m by dA by y as it is, and dA by n by dA by x is what? dA by dA by x of n. n is given in the problem x square minus y square, because n is x square minus y square. And what is its derivative, partial derivative with respect to x? It's 2x. Derivative of y square is 0 with respect to x. So what is this partial derivative? Partial derivative with respect to x means another variables are constants. Y is constant, z is constant with respect to partial derivative with respect to x means another variables other than x, remaining variables or other variables are constants. And so its derivative is 0, y square derivative is 0. And so the dA by dA by x of x square minus x square is 2x. And now we have to solve this equation, and we have to find the value of m. And for that we have to integrate both sides with respect to y, because dA by m by dA by y means derivative of m with respect to y. In order to cancel derivative, we have to integrate with respect to y, both sides with respect to y. So integrating with respect to y, we have integration of dA by m by dA by y with respect to y is m, because derivative with respect to y and integration with respect to y get cancel each other. So we have m is equal to, and this 2x is now constant with respect to y. Integration is with respect to y means 2x is constant quantity, and the integration of constant is what? Constant into variable. So integration of 2x is 2x into y, because y is variable. So integration of 100 is 100x. What is the integration of 100? 100 is constant. So its integration is 100 into x. If the integration is with respect to x, if the integration of 100 with respect to y is 100y, integration of 100 with respect to z is 100z. So what is the integration of constant? Integration of constant is constant into variable. So now y is variable, so 2x is constant. So its integration is 2x into y plus constant of integration in is c as a constant of integration. So this is the value of m. So if you substitute this m at this place, that is 2xy plus c, and if you check whether the differential equation is exact, then what do we have? The dA by m by dA by y, the derivative of this quantity with respect to y is what? dA by m by dA by y is 2x, so derivative of y is 1, and derivative of c is 0. So dA by m by dA by y is 2x. And what is dA by n by dA by x? Is again 2x. The derivative of this x square minus y square with respect to x is 2x. So if you take m as 2xy plus c, c is any constant, then this equation becomes an exact differential equation. So how we can solve these problems? We have to find the value of m such that the given differential equation is exact differential equation. Solve the remaining problems, these problems, that is this problem, number 2 problem, number 3 problem. Okay, we assume that this differential equation is exact and then find the value of m. Similarly, we have to find the value of n in such a way that the equation is exact. So we will solve the second number problem, 6 2. So ln xy means log xy plus 2y sin x dx plus nxy dy is equal to 0. Now we have to find the value of x in such a way that this equation becomes exact. So when this equation is exact, if del m by del y, this is m, del m by del y is equal to del n by del x. So assume this equation is exact, and now we have to find the value of n. So 6 2, answer of 6 2 is given here. Answer of number 6 number problem, 6 2. So ln xy means log xy plus 2y sin x dx plus nxy dy is equal to 0. This is the given differential equation. So suppose this differential equation is exact, then what we have, del m by del y is equal to del n by del x. So I have to find the value of n in such a way that this differential equation is exact. So I assume that this differential equation is exact, and then we have del m by del y is equal to del n by del x. Now m is given. Now in this problem m is given, del y of, in the previous problem n is given and we have to find m. Here m is given and we have to find n. So del m by del y, m is this. So del y of m is log x into y plus 2y sin x is equal to del n by del x, because this is m. Okay, and ln means log, and log x into y, derivative is 1 by x into y. Into rate of x into y with respect to y is x. So derivative of log x is 1 by x, but it is log x into y. So derivative is 1 by x into y. Into rate of x into y is x, plus now 2 sin x is constant quantity and derivative of y is 1 is equal to del n by del x. And so we have x's get cancelled, 1 by y plus 2 sin x is del n by del x. So del n by del x is 1 by y plus 2 sin x. And in order to find n, we have to integrate both sides with respect to x, because del n by del x is the derivative of n with respect to x. So integrate with respect to x. So integration with respect to x and derivative with respect to x of n get cancelled. So we have n is equal to 1 by y, now constant with respect to x, is integration is with respect to x. Means 1 by y is constant, and so integration of constant is what? Constant into variable. So 1 by y into x, x is variable, plus 2 sin x, the integration is minus cos x, because integration of sin x is minus cos x, plus constant of integration. Any c is any constant, and so n is what? X by y minus 2 cos x plus c. So if you substitute this n in at this place, then the equation becomes exact differential equation, because what we have, del m by del, this is del n, now m, and del m by del y is this 1 by y plus 2 sin x. If you find del n by del x, the derivative of this quantity with respect to x is what? 1 by y minus 2 cos x, derivative is minus sin x, so minus 1 has become plus, and derivative of c is 1, c is 0, and therefore we have 1 by y plus 2 sin x, 1 by y plus 2 sin x, that is del n by del x. If you substitute this as n, then, and if you check whether this differential becomes exact, then we observe that del m by del y is equal to del n by del x. So these are the problems of that type. So solve these problems, also these problems in exercise number 2. So also find all m such that the given equation, this equation is exact differential equation. So find n such that the given equations are exact differential equation. So solve all these 4 problems and these 6 problems. So in all total there are 10 problems. Out of that, solution of this and the solution of these problems are given. So solve the remaining problems of this type. So this is also important as far as the exam is MCQ type exam. Then find m if n is given, and find m if n is given, and find n if m is given, if the given equation is differential equation is exact. Next topic is a harmonic function. So what is the definition of harmonic function? A function f(x,y), that is the f is the function of x into y, x and y, is continuous and possesses second order partial derivatives. That is, its second order partial derivatives possesses uh, exist. And then when we say this f(x,y) is said to be harmonic if f(x,x) plus f(y,y) is equal to 0, or we can denote if u as the function of x into x and y, then when u(xy) is called harmonic function if u(x,x) plus u(y,y) is equal to 0. If this equation is satisfied by the function f or u or v, then the function is called a harmonic function. So, and u is the function, then if its harmonic conjugate is v, then v is obtained by using these two equations. What are the two equations? Vx is equal to minus uy and vy is equal to ux. These are CR equations. From these two equations we have to obtain the harmonic conjugate of u. So when v is called harmonic conjugate of u, if vx is equal to minus uy and vy is equal to ux, or we say ux is vy and uy is minus vx. Okay, so in order to obtain the harmonic conjugate we use these two formulas. Okay, so the problem are important. Prove that the function uxy or fxy, u is the notation, x square minus y square is harmonic. So and find its harmonic conjugate of u. So first we have to show this function uxy is equal to x square minus y square is harmonic. So how we can show this function is harmonic? We show this uxx plus uyy is equal to 0. So what is uxx? First find ux. So ux, what is ux? Is 2x. Ux means the partial derivative of x square minus y square with respect to x. So derivative of x square is 2x, derivative of y square is 0. So ux is 2x and then uxx is 2. Right here, uxx means derivative of square u by derivative x square is 2. And uyy, first find uy. So uy is minus 2y and uyy is minus 2. Okay, and so uxx plus uyy is 2 plus minus 2 is 0, and therefore u is a harmonic function. So u is a harmonic function. Now find harmonic conjugate of u. So in order to find, now suppose v is the harmonic conjugate of u. Suppose v is the harmonic conjugate of u, and therefore we have the equation ux is equal to vy and uy is equal to minus vx. So remember these two equations. In order to find the harmonic conjugate, its proof is given here. The proof is not important. So just remember this formula. Ux is equal to vy and uy is minus vx, and therefore vy is equal to ux. Vy is ux. Now we have to find v, harmonic conjugate of u. And what is u? U is x square minus y square. So ux is 2x. So vy is equal to 2x. And vx is minus uy. So vx is minus uy. So what is uy? Uy is minus 2y. And so minus uy is 2y. So we have vy is equal to 2x and vx is equal to 2y. And we have to find from these two equations v. So from this first equation we integrate with respect to y. So vy means integration is derivative with respect to y, and integration with respect to y get cancelled. So we have v is equal to, and the 2x is constant quantity with respect to y. So integration of 2x is with respect to y is 2xy plus phi x. What is phi x? Phi x is the constant of integration. As integration is with respect to y, means x is constant, and therefore constant of integration may be function of x. So instead of taking c as the constant of integration, take phi x as the constant of integration. So integration of this vy is equal to 2x with respect to y is this, v is equal to 2xy plus phi x. Now we have to find the value of phi x by using this equation. So differentiate with respect to x, this equation. So v derivative is vx is equal to 2y, derivative of x is 1, and phi x derivative is phi dash x with respect to x, phi dash x. So right here phi dash x, right, phi dash x here at this place. And then vx, what is vx? Vx is 2y from this equation. Vx is 2y. So substitute 2y. 2y is equal to 2y is equal to phi dash x. Here also write phi dash x. So phi dash x is 0. What we have? Phi dash x is 0 because 2y minus 2y is 0. And so integrating both sides with respect to x. So phi dash x integration is phi x is equal to 0 integration is 0 plus constant of integration is c. And substitute this phi x is equal to c at this place. So we have v is equal to 2xy plus c. Okay, and this is the harmonic conjugate of u. So these are the problems for homework. Find verify the function are harmonic. The functions are harmonic, so we denote u as e raised to x cos y, or u as this function, or u as this function, and show u x x plus u y y is equal to 0 in all these four cases, and find v as its harmonic conjugate by the given two equations. So we will solve this problem number 1. So answer of this out of these four problem, the answer of the first problem, e raised to x cos y. So suppose u is equal to e raised to x cos y. We have to find, we have to show this function is harmonic function. So let u is equal to, or u x y, u write in bracket x comma y is equal to e raised to x cos y. And then what is ux? Is the derivative with respect to x. Cos y is constant, and e raised to x derivative is itself e raised to x. And then uxx means the derivative of ux, again with respect to x. Cos y is constant, and the derivative of e raised to x is e raised to x. Then uy e raised to x is now constant, and the derivative of cos y is minus sin y. And then uyy means the derivative of uy, this quantity with respect to y, minus e raised to x as constant quantity, and sin y derivative is cos y. So uxx is this, uyy is this, and so uxx plus uyy is equal to e raised to x cos y minus e raised to x cos y is equal to 0. So u raised to x is e raised to x cos y plus uyy is minus e raised to x cos y, so become 0. And therefore uxy, or u is equal to e raised to x cos y, that is the given function, is harmonic function. Now let v be a harmonic conjugate of u. Then we have these two equations, ux is equal to vy and uy is minus vx, or we can write vy is equal to ux and vx is equal to minus uy. And so vy is equal to ux is this e raised to x cos y, and vx is equal to uy minus sin uy. So uy is this, minus become plus e raised to x sin y. So this is equation number 1, this is equation number 2. And in order to find v, we have to integrate this equation number 1 with respect to y, or integrate equation number 2 with respect to x. So we integrating the equation number 1 with respect to y, we get vy means the derivative of v with respect to y, and integration with respect to v, integration of this quantity with respect to y, and the derivative with respect to y get cancelled. So we have v is equal to e raised to x is constant quantity, and the integration is with respect to y, and integration of cos y is sin y, integration of cos x is sin x, like that integration of cos y is sin y, plus phi x. What is phi x? Where phi x is the constant of integration, as x is constant, because integration is with respect to y, means x is constant, and therefore the constant of integration may be function of x, and so phi x is the constant of integration. Then we have to determine the value of phi x, so that for that we use this equation number 2. So differentiate this with respect to x. So what we have? Vx, derivative of v is vx, and then sin y is constant, and derivative of e raised to x is itself e raised to x, and derivative of phi x is phi dash x, and then substitute vx as e raised to x sin y is equal to e raised to x sin y plus phi dash x, and so we have the answer of phi dash x is 0, and differentiate, then integrate both sides with respect to x. Integrate with respect to x. So we have phi dash x, derivative integration is phi x is equal to 0, integration is 0, plus constant of integration is c. So phi x is c. So substitute here phi x as c. So we have v is equal to e raised to x sin y plus c. And this is the harmonic conjugate of u. So show the function is harmonic function and find its harmonic conjugate. So this is u function. Then show that uxx plus uyy is equal to 0 and then find harmonic conjugate. Similarly for this problem. So in order to solve this problem, we have to write the derivative of cos y. What is this cos y or cos hy? This is the hyperbolic function. So what is the derivative of hyperbolic function and what are the integration of hyperbolic function? So if sin x is suppose sin hx or sin hyperbolic x, what is its derivative? Sin hyperbolic x derivative is cos hyperbolic x, and the derivative of cos hyperbolic x is sin hyperbolic x. Similarly, integration of sin hyperbolic x is cos hyperbolic x, and integration of cos hyperbolic x is sin hyperbolic x. This is not true for trigonometric function, because we know that the derivative of sin x is cos x, but the derivative of cos x is not sin x. The derivative of cos x is minus sin x. Similarly, the integration of sin x is minus cos x, and the integration of cos x is sin x. But here, if the function is hyperbolic, then derivative of cos hyperbolic x, that is cos hx, is sin hx, and that is cos hx is sin hx, and integration of sin hx is cos hx. Okay. Similarly, cos y. So cos y. This is cos y, cos hyperbolic y. If we have to find the derivative with respect to y of cos hyperbolic y, then it is sin hyperbolic y. Sin hyperbolic y. And if I have to integrate cos hyperbolic y, then it is sin hyperbolic y. So derivative and integration of these functions, hyperbolic functions. So we have to denote this function as u, and then find uxx, uyy. So if we find uxx, then cos x derivative is sin x, and then minus sin x, and derivative of minus sin x is minus cos x. While you have to find the uyy. So uyy is what? Cos x is constant. And what is the derivative of cos hyperbolic y? Is sin hyperbolic y, that is sin hy. And again, the derivative of sin hy is cos hy. And then find uxx plus, show that uxx plus uyy is equal to 0 for this function, also for this function. And then determine the conjugate by using the two equation, that is conjugate, harmonic conjugate, that is v. Suppose v is the harmonic conjugate of u, then write these two equation, ux is equal to vy and uy is equal to minus vx, and by following this procedure, find find this v, harmonic conjugate of that u. So solve the remaining problems of this conjugate function, the remaining 3 problems. So this is about the third topic, that is exact differential equation. So from the previous 2 to 3 lectures, we have seen that how we can show the given differential equation is exact differential equation, and how we can find the solution of exact differential equation. So in the next lecture, we will see the new type, that is the subtype of this type, that is exact differential equation. What is the subtype of this differential? This type is the a differential equation reducible to exact differential equation. That is, the given differential equation is not exact differential equation, but by multiplying integrating factor to that equation, the differential equation reduced to the exact differential equation. That is, the given differential equation is not exact. If we check for the given differential equation, dA by m by dA by y and dA by n by dA by x, like this, that is, the given differential equation is not a differential equation. dA by m by dA by y is not equal to dA by n by dA by x. But by multiplying some factor to this differential equation, this differential equation reduced to the exact differential equation. That factor is called a integrating factor. So the next type is a differential equation reducible to the exact differential equation. The subtype of this type, number 3, that is the differential equation reducible to the exact differential equation. So we will see the integrating factor and that type and the definition of integrating factor in the next lecture.